Okay, well, I guess now it's recording. Okay. So yeah, so I'll do a recording here of graphing log, and I'll share as soon as we get done tonight. Um, so you want to start with the parent function. The parent function is just looking at the most basic log base 2 graph. So forget about the plus 2, forget about the minus 5. Just focus on that, right? Okay, how do we shift it to exponential form? You guys should know that x equals 2 to the y. How do I make the parent table? Because y is now the exponent, we should plug in for y, not for x. So let's say I plug in 0, 1, 2, and 3. 2 to the 0 power is 1. 2 to the 1 power is 2. 2 squared is 4. 2 cubed is 8. Okay, any questions on that? Someone's asking, I forgot to submit the most recent homework. Yes, just turn it whenever you can. Don't worry about it. Okay.
Wait, Mr. E, why do you need to do that? Can't you just do like the log 2 and then x minus 2? Couldn't you like plus 2 and then like couldn't you add or what's like covered behind like that red?
Well, now I'm going to uncover it. So now I'm going to make a new table.
But couldn't you first just can you just do like x plus 5 and then you could do like y equals b to the x and then just do like 2 equals y minus 5 equals x plus 2? Or like, could you do like that? I didn't get like the numbers right, but like, could you do that?
Wait, do 2 equals what?
Well, so you add 5 to the other side, so and it's x.
Oh, I see what you're saying. I see what you're saying. So you're saying do y plus 5. You're saying do this, right?
Yeah, yeah,
Then 2 to the y plus 5. Okay. And then subtract 2.
yeah, and then just do like the table like that, so you don't have to do.
Okay. I've not taught it that way. So someone else taught that too. Who taught that to you?
That's just how I've done it this whole year.
Well, we've only done it for 2 months, so it's not the whole year. But I mean, it's okay. I mean, if a tutor taught you that way, or if someone at AAC taught, did someone at AAC teach you this way, or a tutor?
No, I honestly don't even know. I've just like done it that way this
Yeah.
whole time.
Okay, you could do that. I'm not going to teach it that way because I have to teach a consistent method
Okay,
for teaching transformations because I have to give you a method that's transferable to other functions, like because we're going to be doing trig after this unit.
okay,
And that technique does not only applies to logs, does not apply to anything else.
okay,
As you guys move on to pre-calculus, because when you get to pre-calculus, the first unit, you're given a barrage of equations. Um, kind of like what's the good analogy? I mean, I can always use a baseball analogy, like, hey, you're seeing a curveball, you're seeing a fastball, you're seeing a slider, you're seeing a changeup, whatever. You have to be able to handle all those different situations. It's kind of the same thing with graphing functions. Like if you get a lot of different graphs, fine, but you still need a consistent technique you can apply to all those different types of functions. And that's why I'm doing it this way.
okay. All right, thank you.
Um, so now let's make a new table. So drop by 5 for the y values, right? Because that's what the minus 5 does. The plus 2 means you're going to take away 2 from x, because x plus 2 equals each of these. So you have to take away 2. So negative 1, 0, 2, and 6. Now the asymptote for this, for the parent function, was that x equals 0, right? Because x cannot be 0, because you can't raise 2 to some power and make it 0. It's impossible. And you can't log 0 or negative numbers either. But because of the plus 2, which caused a shift of 2 left, my vertical asymptote will be at negative 2. So when I plot the points, you'll have points pretty close to that. So for example, negative 1, negative 5, 0, comma, negative 4, 2, comma, negative 3, and 6, comma, negative 2. Then I'll need to move the screen just a tad. And done plotting points. So now I'll graph this. There we go. Okay. So let me stop that recording. So I'll just call it graphing the logs.